All right, so as we move on here with oxidation numbers, here's my fourth rule. Oxidation numbers are written per atom, okay? And I'm going to show that as an example as I go through. So let me just keep going. So just know that it's written per atom. You'll see that when we do something that might have a polyatomic ion with it, okay? The algebraic sum of the individual oxidation numbers of all atoms in the compound are always 0. Again, I'll show you that as an example in just a moment. But you just saw that when I did the hydrogen peroxide as to why oxygen is not a -2 in that case. It usually is a -2, but if in that case it wasn't. And the algebraic sum of the individual oxidation numbers of all atoms in a polyatomic ion is equal to the charge of the ion. I'll show you an example of that. So let's just do examples. Let's say I have Na2SO4, sodium sulfate. Sodium sulfate. A little bit hard to see on there, but hopefully you can see it. Na2SO4. Know that the reason it's Na2SO4 is because Na is a positive charge, SO4, the sulfate's a 2-, so you need 2 of the NAs to balance off that sulfate. You cool with that, with how we put it together? Okay. Now, to put it in terms of oxidation numbers, we need to do it per atom, which means we're going to have 3 oxidation numbers for this one. Sodium is a +1. Why? Because it's in that alkali earth, the alkali metals. It's a +1. That was one of those rules. Okay. Oxygen is a -2. Why? Because that was one of its rules. It's very few times that oxygen won't be a -2, and that's when it's with something else that has another rule, like in the case of hydrogen. But notice, sodium a +1, oxygen a -2. Now we have to have per atom, which means sulfur also has to have an oxidation number. Okay? But because the algebraic sum of all the individual are equal to 0, we can figure out what sulfur's is by looking at how many sodiums and how many oxygens we have. I have 2 sodiums, each at a +1. That means I have +2. Okay, right? You see I have 2 of them, of my +1s. That's a +2 for the sodium. Oxygen, I have 4 at a -2, which means -8, right? 4 -2s is a -8. So we're looking for sulfurs, and I only have 1 sulfur. What must its oxidation number be? +6. It must be a +6 because the algebraic sum must always equal 0. So the oxidation numbers for this thing right here, Na2SO4, is a +1, +6, -2. Okay? Again, you do it per thing. So it's a whole deviation. We're deviated from when we were doing charges. When we did charges, sodium had a +1, sulfate, SO4, which is the sulfate, had a -2, and then we balanced them. So let me do another one. Let's say we have no, let's not do Na. Yeah, let's do Na. NaC2H3O2. Okay? Just as a reminder, just see if we can remember from last year, what was the charge on this thing? Excuse me, not the charge. What was the name of this thing? Sodium acetate. Jeremy remembers that it's C2H3O2. That's an acetate. Okay? Now, the reason the formula is like that is because sodium's a 1+, C2H3O2 minus, so we have a 1 + 1 minus, that's just NaC2H3O2. Now we need to assign oxidation numbers. How many oxidation numbers am I going to have? No, I'm going to have 4 because oxidation numbers are written per atom. And if I have an Na, and I have a C, and an H, and an O, I need 4 oxidation numbers. So let me grab a different color here just to, let's go white. All right, sodium, +1 oxidation number. Because it's sodium, it's a rule that it has a 1+ oxidation number. What's the oxidation number on, I'm going to save the C because that's one of the ones we don't know. What's the oxidation number on H?
0, 1.
+1. Why +1? Because hydrogen has a +1 when it's anytime with a non-metal. Notice it's with an O in there. So it's a +1. What's oxygen's oxidation number? -2. Because it's oxygen. If you remember from the slide before where I gave you values. So that means that carbon's the only one we don't have. Let's figure out what the totals are. No, let's figure out what the totals are so that we can figure out that the algebraic sum adds up to 0. So sodium is a +1, I only have one of them. Carbon, I don't know what it is, I'm going to put a question mark. Hydrogen is a +1, but I have 3 of them, so that's a +3. Oxygen, I have 2 at a -2, so that's -4. So if I have 2 carbons and I have -4 + 3 -1, what must carbon be? It's 0 in this case. Now you guessed it being 0, but you're right, it is 0, okay? It looked like it needed to be 0, okay, that was a good guess. So there's the oxidation number for carbon because again, this must equal 0. All right? So that's the that's number 5. Now, that basically talks about number 4 and 5 on this page. The algebraic sum of talking about polyatomic ions, basically that's this right here. If I have PO4 with a 3-, can you see that black? Not really. Let's go to white. PO4 with a 3- charge. So if we have a formula that has the PO4 with a 3-, oxygen is going to have, let's go to this screen, a -2. It's pretty much always a -2. And we have 4 of them, so that's -8, right? What must phosphorus be if the algebraic sum must be equal to the charge? It must be a +5. I only have one of them, so +5 oxidation number for the phosphorus there. Okay? Any questions on that? All right, let's stop it right there for now.